Cool. Let's get started. So before getting started, how many people are here because of crypto? Versus how many people are here because of AI? Okay. So I have a close to zero content about crypto. I'm solely going to talk about AI. But I am holding Bitcoin and Ethereum. So I'm pro blockchain. Right, so I'm going to talk about the open source LLMs and to production. So I am working at Databricks and I work for the AI code autocomplete feature. And I'm going to introduce you some interesting aspect about building this product. So this will be very focused on engineering products, how we made it happen, etc. So starting with the one slide about AI code assistant. So I think it's not doubtful that the AI or code assistant is one of the most successful LLM applications as of the year 2025. So you may hear a lot of different stories and some horror stories about the different AI agents that's writing really good code, GitHub Copilot, Cursor AI, they are making the developer product really go up above the roof. There's the different interesting articles about a lot of new code are now actually generated by AI, and there's an interesting discussion on will software engineers replaced by AI. So unfortunately or fortunately, I'm not going to talk about if software engineers will be replaced by AI. I'm actually going to go deeper into this AI code assistant and talk about what type of different aspect that I need to thought about on building the customized solution. So why at Databricks, our team decided to working on a new domain-specific solution? So as I mentioned on the earlier slide, the AI code assistant space is going pretty crazy. There are a lot of great solutions out there, and then maybe people think there's no need for the additional solutions. But however, our thinking was slightly different because users of Databricks has a very specific type of persona. So they are either working on data engineering, data science, or some AI-related code. The types of code that they are writing is subset of the types of code that's written by the entire world. So out there are a lot of solutions that's doing, in general, very well for all these different types of coding. But we wanted to come up with a solution, one that's really excel at our domain-specific problems, and two, that's working well with our existing product. So that's why we decided to come up with the new feature called Databricks Assistant Autocomplete. So before going further, let me properly introduce myself again. So I'm Evion Kim. I'm working as a staff software engineer at Databricks. I'm one of the founding members of the Applied AI team. So I worked on the multiple different companies on multiple different products. And all of the product has one commonality, which is it is the intersection of data, AI, and software engineering. So if it was a talk that I'm giving 5 years ago, I would have said machine learning, but now it's 2025, so I'm going to say I'm working on AI. And in case you are not familiar with Databricks, so Databricks is the cloud-based platform for data engineering, analytics, and AI. So we are providing the enterprise solution that any enterprise can build their data stack without too much hassle on top of their cloud. And one more quick disclaimer, so whatever I'm going to talk about today, including the fact that I am pro Bitcoin, etc., that is all my personal opinion, has nothing to do with Databricks. Read the disclaimer there, please. Cool. So we talked about building the customized AI solution, and there will be, of course, numbers of different challenges there. And I'm going to talk about three big challenges. The one, AI challenge, two, engineering challenge, and three, product challenge. So I'm not going to go into the details of all the different challenges that we faced, but I'm going to give you one or two interesting aspects that we faced when we were building the product and how we solved it. So for the AI part, what I want to talk about is what type of AI LLM model we used and how we used it. So we had a very specific need. We had a need that we need a coding model with certain criteria, and that's doing really good on the domain that we want it to be excel at. And also, we want it to be done on the lower latency while not burning out tons of money. So that was our AI challenge. And the engineering challenges, so again, there are many different engineering challenges there, but one of the engineering challenges I want to talk about here is that given that we are coming up with the solution, how can we know was successful? And how can we actually iterate so that we can, if it was successful, make it better. If it was not successful, how to make it successful. So there were this engineering challenge there. And the product challenge. So assuming that we came up with great AI, great engineering, but in the end, what we're talking about is user-facing product. So can we actually turn this good engineering and AI into the great product? So these are three big themes I'm going to talk about. Okay, so this is the first slide about the first slide, so AI challenge. So our solution first. So we decide to use the open source large language model plus domain-specific fine-tuning. So why we decide to do that? So if we are only care about the coming up with utilizing the model that's doing really good job on coding and the reasoning, then we can just pay for the ChatGPT API and then get the great answers with maybe some higher latency and with some cost. But however, what we needed was not exactly that. We wanted to be really excel on the two languages. So if you take a look at the left bottom, it is Python, the typical user data engineering Python code. And the right bottom is a SQL code, typical users data analytics SQL code. And there are many different packages that users are frequently used further. Like for example, all the data engineers, not all, but most of the data engineers like to use Pandas data frame. And also, since we are Databricks, that's built on top of the Spark engine, so a lot of people are using the PySpark library. So we wanted to use the free model hosted by us, and then wanted to customize it in a way that it excels on the specific domains we want it to be doing well at. So there comes domain-specific fine-tuning. So we tried out different approaches, but one of the approaches that was working well was get the public data. So there are a bunch of crawled publicly available coding data, and we ran the ETL on it to get the subset of those training data that is composed of the types of codes that we wanted to have. So we are talking about the notebook code, SQL code, and code that has certain packages in it, etc. So with those subset data, we did the fine-tuning of our base model using those data. So to be very exact, it is not fine-tuning, it is continued pre-training. So there is some slight distinction between if you're continuously doing the pre-training versus fine-tuning, but I'm not going to go into details there. So whenever I say fine-tuning or continued pre-training, they are exchangeable in this talk. So we were able to get the model doing the good job by getting this custom data that's already publicly available, but just a subset of data, and then continue to pre-train the model based on that. So actually, I just said that we were able to get it doing the good job, but the question is, how do we know if it's doing the good job? So there was my second slide. So how do we evaluate? So if you ever worked on the LLM, so evaluating if LLM and its solution is doing well or not is a very, very painful thing to do. So LLM is always coming with some language, and that language can be, when we are chatting with each other, there can be multiple different follow-up answers that can be right or wrong. So when LLM comes up with some answer, it is very hard to validate if it is right or wrong. However, luckily for coding, it is relatively easy. But because any code that's generated by someone is very easily verifiable. So that's where our benchmarks kicks in. So there are numbers of different generally available coding benchmarks. They are all looking in the format of the upper right. So it is composed of a prompt and test cases. So for example, one test in the benchmark says, following is a quicksort algorithm, DEF quicksort. finish it. Then model trained to complete this type of code will complete it with a quicksort algorithm or not. After it goes through the prompt and the generation, we can easily verify if it generates the right answer or wrong answer. So how do we know if it generates the right answer or wrong answer? That's very similar to what we did in the software engineering. We are writing the unit test. So on the second black column there, it has assert about if this quicksort function was actually sorting the left array into the sorted manner. So if model was generating the right quicksort algorithm, it will actually sort it. If not, it will fail or it will do something wonky. So this is the very basics about how coding benchmarks work. So we actually came up with the idea of let's do the general coding ability benchmarks run for all our models, along with come up with our own custom benchmarks. So how did we come up with the custom benchmarks? So as I mentioned earlier, so we have a specific set of language, specific set of packages that are frequently used by Databricks users. So we just decided to come up with manually create this prompt and test cases for those example cases. Plus, after that manual creation, we also decide to utilize other powerful LLM to synthesize this type of test cases. The one idea that I didn't write down in detail here is that if there's an API document about something, we can feed that API document into the very large language model and then ask it to come up with the test cases that can test the function. So this combination of manual and LLM generate test cases, so we were able to come up with a couple hundred of different test cases that compose of a good benchmark. So after that, what we did was whenever we fine-tune the model, we are actually very advanced through the general coding ability benchmarks and the domain-specific coding ability benchmarks. And then we can get the overall model capability of it. One more thing I want to kind of brag about here is that actually this is the composed of two-stage solution, the generation and the evaluation. And on running the evaluation, it can be pretty dangerous. But we have no control over what LLMs will be writing. For example, LLM can decide to write RM minus RF or decide to format your computer. So how do we prevent that? So there can be multiple interesting ideas that we can come up with, but we just decide to sandbox our running environment. So we have a custom Docker sandbox running environment, and the generation is done from our GPUs, and it has just a text file that contains all the generations, and it's passed to the Docker sandbox environment, and then it just runs there. So even if it's messed up the environment, it will just mess up the Docker container. So with that platform in setup, we were able to, one, evaluate how well model is doing, and two, iterate to find a good model solution. Okay, so with all these great innovations that I talked about, we were able to launch our model. And launch the model. After launching the model, we were closely monitoring, and of course there were good feedbacks, bad feedbacks. We were taking a look at if users are accepting it, not accepting it, etc. And there was a one interesting pattern that we found out that was making users very unhappy. So take a look at the right upper SQL query there. So this is the simple SQL query that's trying to get the click percentage from the table. So date and click count times 100 divided by show count, so it will give you the click percent. Simple, and it's complete as is. When we run this kind of code to our model, it actually decides to generate more contents to it. So if you take a look at the bottom right, it actually added the two additional columns there, click count and the show count. So they are not necessarily wrong, because that's still generating the click percentage per date across all time, but they are unnecessary. So the first one was already complete, and we don't want it to generate anything. So contradictorily, we are talking about the generative AI here, but here we came up with the new problem of know when to not generate. So that was actually degrading our user experience quite a bit. So we teach the came up with a couple different ideas, and one of the ideas was working particularly well, which was pretty simple trick. So during our fine-tuning process mentioned in the 2 slides earlier, we decide to add the additional training data that's composed of empty response. So the 5 or 10% training data are just composed of empty response, not saying anything response. On top of that, on the slide before, we talked about coming up with custom benchmark. On those custom benchmark, we added this empty generation specific benchmark cases as well. So in there, what we did was we gave it a lot of complete SQL, complete Python code, and see what model does. If model is not generating anything, it is pass. If not, it's fail. So after doing this quick trick, and then adding this benchmark to measure that, so we were seeing that for SQL cases, we were able to get the model going up, the benchmark score going up from 60% to 97%. And then, believing that's the good number, we added it to the actual production, A/B testing it, and we saw the clear increase in the code suggestion acceptance rate. So surprisingly, out of all the things we tried, this was one of the most important feature breakthrough that we had done to make it better product for the users. Okay, so coming back to this fancy 3 circles, so how we built the custom AI solution. I talked about AI engineering product challenge. So for AI, we decided to use the open source coding model for fine tuning. The reasoning was because one open source model, we can do fine tuning whichever the way we want to do it. And also they are cheaper, they are more secure, and they can do a great job after our fine tuning on our specific domain we want to excel at. Engineering side, so how do we measure the success? We were able to measure the success through generally available benchmarks and the customized benchmarks. And the third, last but not least, product challenge. So we continuously monitor the user feedback and the user's metrics, etc. And given that we have AI and engineering solution in place, we were able to flow them user feedback back into the AI and the benchmarks so that we can come up with a solution that's customized and optimized for the user experience. Okay, I have one more slide left, and the last slide is super important. So I'm working for the applied AI team, and the AI coding assistant was one of the products that we are working on, but we are working on a lot of different cool products, especially the LLM power product that is helping users excel at their job. So we are actively hiring, but if you are interested, please email me, send me LinkedIn email or personal email, etc. Okay, that concludes my talk. Thank you very much. Any questions?
In the fine-tuning stage, have you tried DPO, direct reference optimization, or GRPO?
We actually did DPO. So we did a DPO after the continuous pre-train. Actually, I'm not sure if it was publicly available also or not, but yeah, we did the DPO too. Based on some hallucination synthesized data that we made.
Is it after SFT?
So 2 things. One, to be specific, our fine-tuning was not SFT because it was not instruction fine-tuning. We actually had a bunch of code chunk, and then we permuted it, and then continued pre-training. Yeah. But after that stage, which we call it fine-tuning or continued pre-training, we did the DPO training further.
Oh, so you didn't do supervised fine-tuning?
The reason why we didn't do the supervised fine-tuning was because in here the question was not about answering the question. It was more about, given the code context, can you complete the fill-in-the-middle chunk? So we got the fill-in-the-middle chunk, the trained model, and then continued pre-training. So it does good job on the task it has. Any other question?
I went to the Databricks workshop before for AI. One thing actually that didn't have is a semantic search pattern, like Elasticsearch will do. So the fidelity you can do on Databricks or precision is Databricks don't provide toolset to semantic search documentation. You can understand why that? Because I was there in Mountain View last week and I tried to figure out how to use it because it's much more less accurate than I need to be doing. And less high quality production for access.
I see. So if I understood it correctly, you tried the semantic search and it was not working well.
You don't have
I'm sorry?
you don't have Elasticsearch, that kind of semantic capabilities. Search pattern. It's not part of the product.
I see. So
Correct, it does not behave exactly how the precision we need to be able to lock down the graph and preview all content.
I see. Okay. So this is not exactly related to the part that I am working on, so I will try my best to not commenting anything that's going to be beyond what I can comment. But however, I know what search team is doing, and they are doing like relentlessly working to make the things improve further. So if you check back with us maybe a month later, you will see something different because we are working on the new product every day. Oh my God, I sound so like pro corporation. Oh my God, I love decentralization. I'm not centralized person.
So you mentioned that you created the custom data set for fine tuning, and that there's a mixture of manual as well as LLM generated prompts and test cases. How do you ensure the integrity and accuracy of the LLM generated test cases?
So the question is, how do we check the integrity of LLM generated test cases? The answer is manually checking.
Okay.
So there are a lot of test cases, but they are not that many. So we have about few hundred test cases in the end. So if you just grind a couple junior engineers for, I don't know, what week or so, then you can test them all. Did that answer your question? Or?
Yeah. I mean, I was curious if you considered like using like a much larger and competent LLM as a judge to automate it, or like multiple LLMs, and then find where they disagree and then give it to the junior engineers, or.
Oh, I see. So I may have not been that clear on the test case generations. Actually, test case generation done by LLM was based on the much larger language model.
Right.
And then we also had actually this was a multi-step effort. So we had a generation part, and there was another LLM kicking in to validate if it's good or not. So there were multiple LLM checking followed by the junior or senior people grinding to test it if it's good or not.
How long do you think to build this product? And how many people do you think
In terms of from the ideation to actually making it the product, so actually it's hard to tell because some version of the AI Autocomplete was already there. Our team's main contribution was update the model to the domain-specific model. But if you're just talking about from the ideation to actually become generally available, how long did it take? I think initial version rollout took about 6 months-ish. So the private preview took less than 6 months, and then the actual GA, it took about 6 months, and then after that we are continually working on it. So far I've been working with this project for a year plus. And also, just to mention one thing, so I just mentioned a couple interesting points from this entire product journey. Actually, there are a lot more things happening in front of this, in back of this, post-processing, how it's being done, are we using the other models, etc. If you're interested, you know where to contact. Cool, thank you very much.